This video covers section 5.4, dividing monomials, the quotient rule and integer exponents. Objective 4, simplify exponential expressions involving negative exponents. The expression at our hand is z cubed over z to the fifth. We see now that there are more z's on the denominator than in the numerator. And when we subtract the denominator's exponent from the numerator's exponent, 3 minus 5 is negative 2. Looking at the expression in another way, saying that there are 5 z's on the bottom and 3 z's in the top, we see that these z's can be crossed out, and we're left with 2 z's in the bottom, and everything's gone from the top, leaving us with a 1, leaving us with 1 over z squared. So we make the conclusion that z to the negative 2 and 1 over z squared are the exact same expression. This leads us to the following result. We see that from this expression z to the negative 2, it gets put in the denominator as a z squared. Having a negative exponent means to put it in the denominator. That is a reciprocal. If we see something like 3 to the negative 1, that is thought of as a 1/3 or reciprocal of 3. The remaining number that gets left, for example, in 2 to the negative 4, 1 over 2 to the fourth is just the exponent. So the negative on this says to take the reciprocal. The 4 on that says to take the fourth power. 1 over 2 to the fourth is 1 over 16. So in short, a negative exponent is a reciprocal. Letter B, this is negative 2 raised to the negative fourth power. With the parentheses, the exponent sees the entire negative 2. So it puts the entire negative 2 in the bottom because of reciprocal and then to the fourth power. And when you have 4 negatives, it becomes a positive, and 2 to the fourth is 16, giving us 1 over 16. Letter C, when there aren't any parentheses, the negative is not seen by the exponent, and therefore it is just the reciprocal of 2, and then we raise that to the fourth power. That's 1 negative, 2 to the fourth is 16, giving us negative 1/16. Letter D, we have a subtraction symbol in between 2 exponents. And exponents in PEMDAS come first. So we take 4 to the negative 1, which is 1 over 4, minus 2 to the negative 3 is 1 over 2 cubed. We get 1/4 minus 2 cubed is 8. We need a common denominator here to subtract these two fractions. So we multiply 1/4 top and bottom by 2, giving us 2/8 minus 1/8, which turns out to be 1/8. Example 5, y to the negative 8 is 1 over y to the 8th. Negative y to the negative 8th is 1 over negative y to the 8th. With the parentheses around the negative y, the negative and the 8 sees that negative y, so it stays in parentheses, and 8 negatives is a positive, and y to the 8th is y to the 8th. Letter C, without the parentheses, the negative is not seen in the front. It's just a negative. 1 over y, and the negative on the 8 says to take the reciprocal of y and leave that to the 8th power, giving us negative 1 over y to the 8th. Keeping up with the theme of parentheses versus not parentheses. 2m to the negative 2, just the m is seen by the negative 2. The 2 is going to stay on the top, and the m to the negative 2 is going to go to the bottom. If I have 2m and that's raised to the negative 2, then I take the reciprocal of the 2m and gives me 1 over 2m to the positive 2. 2m to the positive 2 is 2 squared, and m squared, or 4m squared. And letter C, with the parentheses, that entire negative 2m is seen by the negative exponent. So I take the reciprocal and square the negative 2m, which leaves me with 1 over negative 2m squared. When you square a negative 2, it becomes positive 4, and square an m becomes m squared. This leads us to practice 2 for you to try. I encourage you to press pause on your video and work these out and come back when you're ready to see the solution so you can check your answers. Now that you've had a time to check your answers, we were going to work these out together. Negative 2 times x to the 0 is negative 2 times 1, which is negative 2. The opposite of 3 to the negative 2, that's 1 negative, not seen by the exponent of negative 2, so it gives me 1 over 3 squared, which is the opposite of 1 over 9. With the parentheses, the negative 3 is seen by the exponent of negative 2, so it's 1 over negative 3 to the second power. Negative 3 to the second power is 2 negatives, which leaves me with a positive 9. With an exponent of negative 3 outside the parentheses, everything gets moved to the bottom because it's in parentheses, and now it's to the third power. When we raise negative 3 to the third power, that's 3 negatives, which gives me negative 27, and then m cubed. So that's negative 1 over 27m cubed. Moving on to the next idea, what if the negative exponent is in the denominator? If it's 1 over 3 to the negative 1, then we think of that as 1 over 3. The numerator is 1, and the denominator that we're dividing by is 1/3. 1 over 1 divided by 1/3 is 1 over 1 times 3 over 1, which gives me 3. So in short, we say that if the denominator has a negative exponent, then you place it back in the numerator. So we're just moving them back and forth. We already saw that if it was in the numerator, it goes in the denominator. So now we're saying if it's in the denominator with a negative, put it up in the numerator. 1 over 3 to the negative 2. The 3 to the negative 2 goes to the top as a 3 to the positive 2, and that becomes 9. 1 over the opposite of 10 to the negative 2. That's just a negative number. I'll put it out in front of the parentheses, but then the 10 to the negative 2 goes to the top as 10 squared. That's 1 negative and 2 factors of 10, which is negative 100. Letter C. The 5 and the 2 have no exponent on them, so we leave them right where they are. But the z to the negative 2 goes to the top as a z squared. And the last idea for negative exponents is if it's a fraction raised to a negative exponent, it's just the reciprocal of a over b, which is b over a. One way to see that is we know that a to the negative n over b to the negative n is the same thing as a over b to the negative n. Now, if it's on the bottom with a negative exponent, place it on the top. If it's on the top with a negative exponent, we place it on the bottom. So example 8, letter A, we want to make all those exponents positive, and we achieve that by knowing that the 7/8 to the negative 1 is the reciprocal of 7/8, which is 8/7. If it's 3a over 5 to the negative 3, then we take the reciprocal of 3a over 5 and write 5 over 3a. And then that's to the positive 3 exponent. Gives us 5 cubed divided by 3 cubed times a cubed. 5 cubed is 125. 3 cubed is 27, and a cubed. Letter C, we treat the negative on it first, which is the reciprocal, so everything gets flipped over. Now the exponent's a positive 2, so we come along and square every one of our numbers. Negative 3 squared, n to the 4th squared, and 2 squared. Negative 3 squared is 9, n to the 4th squared is n to the 8th, and 2 squared is 4. This leads us to your practice problem. I encourage you to press pause on your video and work these out, and come back when you're ready to check your answer. Now that you've had a chance to work these out, letter A, x over 7 to the negative 1, that's the reciprocal of x over 7, which is 7 over x. Letter B, 5 over 2x to the negative 2, that's the reciprocal of 5 over 2x, which is 2x over 5. We take the reciprocal, and now we have a positive 2. Now we raise the 2x to the second power, which is 2 squared and x squared over 5 squared. That leaves me with 4x squared over 25. Letter C, we treat the negative first, which is the reciprocal of the expression inside. 4 goes on top, and 5x to the 4th goes on the bottom. Now we attach that negative to the 4 and square it. Attach that 5 to the exponent of 2 and the x to the 4th to the exponent of 2. Negative 4 squared is 16. 5 squared is 25. X to the 4th squared is x to the 8th. This concludes the video for section 5.4, dividing monomials, the quotient rule, and integer exponents. Objective 4, simplify exponential expressions involving negative exponents.